So I wrote our answer to A again, and now we're going to do part B, which is let's see what the shortcut has to offer using the second fundamental theorem of calculus. So again, I note that they're both variables, so I will be plugging in and taking the derivative. This one, you go first. So I'll have 1 over x squared squared times the derivative of the expression, which is 2x, minus, and then I'm going to plug in the bottom one, so 1 over x squared times the derivative of that expression, which is just 1, and now I'll simplify. So here in the front, I'm going to have 2x over x to the fourth minus, and the second one is 1 over x squared. I'm going to simplify this one first. So I'll get 2 over x cubed, and then I'll make the common denominator. So I'll have to multiply by x. And so, oh my gosh, look, I'm going to get 2 minus x over x cubed. It's the same thing. No way. So just a little bit of a recap. If we take the antiderivative of velocity, of course, we end up with position. And since that's indefinite, it would have a plus c. And if we take the antiderivative of acceleration, we'd end up with velocity. I don't think this is a new thought for you. We'd end up, antiderivative of acceleration would give us velocity. And so, but remember, in the past, when we found final position, we did the position ending minus position starting, which really was like doing S of B minus S of A. And since the fundamental theorem of calculus is going to give us that, right? If I actually evaluate that, I would have the antiderivative of velocity would be position, and then from A to B. So it ends up being exactly that, S of B minus S of A. Pretty cool, huh? So I can now use that to find displacement. And then the other thing that we did was we found distance traveled, and we had to split it up because we had to worry about whether it was traveling in a positive direction or a negative direction. So we looked at when is velocity positive and when is velocity negative, and then we split it up so that we could find the position across those intervals. So now I could actually do that by simply integrating from time 0 to time whenever I'm interested in, and I'll integrate the absolute value of my velocity to get my distance traveled. Now, one other thing is you're going to need this little note when you're working the problems. On problem 14 on the 4.4b set, it's going to talk about directly proportional. And so when that's true, you're using the equation, it's just a linear equation where k is the constant of proportionality. Fancy title, isn't it? K, we introduce k, the constant of proportionality. Sounds like the king of something. And so on problem 14, I don't have it here to look at, but I remember it has something to do with this.